Hey Emily, so you've asked about a couple problems and I have them here and I'm going to be able to show you how you can work on these problems. So the first one you had in question is this one here, number 2, page 418. It says water pours into a tank at a rate of 16 gallons per minute until the tank is full. Then the tank is drained at a rate of 20 gallons per minute until it is empty. The tank drains 12 minutes faster than it is filled. How many gallons does it hold? So whenever you're trying to deal with rates and you're asking to compare things, I always suggest that you kind of create a table for yourself. So, and knowing that this problem is and looking at it, um, the best strategy which we can use is the backdoor strategy, since it allows us to pick any number and helping us to actually not the backdoor, actually the trial and error strategy in trying to solve this one. So as we mentioned, water pours into a tank at 16 gallons per minute. So it fills at 16 GPM. I'm sorry, this is really bad. Okay. And then it drains at 20. Okay. And what we're trying to figure out is have a differential that the tank drains 12 minutes faster than what it fills. So it fills 16, drains at 20, and we want to know how many gallons in the tank does it hold to get the differential of 12 minutes. So in looking at this, and once again trying to choose numbers that help us easily to manipulate and to calculate on this, I'm going to select 10 because 10 is a very good multiple of both 16 and 20. So if, or so not 10, sorry, excuse me, I'm going to choose 160. My bad. 160 is both a multiple of 16 and 20. It divides quite evenly into them and stuff, so we're not having any sort of decimals and that. So if I have a 160 gallon tank, 160 gallons, fills at 16 gallons per minute, that means it takes 10 minutes for this tank to fill. Okay, 10 minutes. And then also if it drains at 20 minutes per minute, so if it drains 20 minutes per minute, 160 divided by 20, or 20 gallons per minute, then it's going to give me, it takes 8 minutes for it to drain. Okay. Now my differential between the two, let's create another column over here, is 2 minutes. Okay. And we're looking for 12 minutes. We want a differential of 12 minutes. It's at 2 when it's at 160. So basically I can multiply this by 6, which will then give me 12 minutes. 6 times 160, entering that into my calculator gives me 960 gallons. If I divide that by 16 gallons per minute, it takes 60 minutes to fill up. And if I divide that by 20 minutes for the drainage of the tank, it takes 48 minutes to drain. And that's how we solve that problem. Okay. Next one. Let's see if I can scroll down here. Let me erase. Let me, not going to allow me to. Let me pause and reset. Okay, and this next problem as such is we're working on ratios. And once again, kind of when you're working with rates and ratios, I really encourage you to kind of draw things out and you're setting up, and helps give you a better visual. So we have team A. So we have team A here. And it tells me that team A has 15 boys. So 15 boys and 3 girls. Okay. And then team B has 5 boys. Okay, 5 boys and 7 girls. Alright. And it says the two teams trade players. Team A sending boys to Team B, while Team B sends an equal number of girls back to Team A, until the ratio of boys and girls is the same for both teams. At that point, a total of how many players will have changed teams. So we'll take this one at a time and progressing through this. So our first attempt, alright, Team A is going to send one boy over, so they'll have 14, and they're going to receive one girl, so they'll have 4 girls now. While Team B will have 7 boys, no, sorry, 6 boys, okay, and 6 girls, okay. Well, those do not match up. That's 7/2, and that's a ratio of 1, so that does not match. So once again, sending one boy over and then a girl over this direction. Now we have 13 boys on Team A, and we receive one girl, which is now gives us 5. We now have 7 boys over here, correct, and 5 girls. Once again, these do not align with each other. So how many players have we changed? 1 went this direction, 1 went this direction, so that's a total of 2. Okay, again, 1 went this direction, 1 goes this direction. That's another 2, so that's a total of 4 players. Next attempt, we'll send 1 more boy over, so now we have 12 boys here, and we receive 1 girl, so that means we have 6 here. Now they have 8 boys, and they lost a girl, so that's 4 girls. So now we've got a ratio, as you see, 12/6, 8/4, or it reduces down 2/1, and then we moved another 2 players over. We moved a boy, we moved a girl, so now we've got a total of 6, and 6 is our answer. All right. Okay, now the exponent problem, which you spoke about and inquired with. Now remember, exponents, you cannot add and subtract, you can't do squat, okay, or add and subtract, you can't do jack. You can, when they're the same bases and multiplying, you can add, and when you're dividing into the same bases, the things, you can divide. So let's write this problem out a little bit more. So we have 2 to 500, all right, minus 2 to 499. Oh gosh, this is really bad, sorry. I need to get a better mouse. 2 to 400 minus 2 399. All right, I think you know what I'm talking about. You can see this, although it doesn't look like much. And then we have 2 to the x power. So what we do have, and which you can see here, is here we have 2 to the 500 minus 249, 2 to the 499. Well, knowing that you just multiply 1 more 2 times 1 more time, we can pull 2, sorry, reach that. We can make that bigger. Pull 2 to 499 out of the equation, okay? And we're left with 2 minus 1. So if you see this, 249 times 2 gives us 2 to the 500. This is just multiplying 2 one more time to this. And then you have the negative 1, so 249 minus, or here times negative 1 gives us minus 2 to the 499. So we're going to do the same thing over here. We're going to pull 2 to 399 out. So we're just factoring is all we're doing. So then we're left with 2 minus 1. Alright, equals 2 to the x power. Alright, so that's what we've done. We just factored these out. 2 to the 499th power times 2 to the 399th power. This is what we're resulting left with and things. Knowing this, we can now eliminate these. You know, basic factoring, eliminate these bases here, such. So now we're left with 2, 499, make that a little bit clearer, minus, or sorry, not minus, times 2 399. These are horrible nines by me. Okay, equals 2 to the x power. So again, we're trying to factor these out and things. And what base can we now factor out at this moment? Well, we have 2's that we can factor out. And as I mentioned, when we're multiplying these exponents, we can add them together. All right. So we've eliminated our 2. We factored out our 2's. Now we're left with 499 plus 399. I don't like that 9. Come on, work with me here. Work with me here. It's not going to work with me. Okay. Equals x. Okay. Add these together. We now get 800. Come on. Why do you not want to draw circles for me? Come on. There we go. 98 equals x. There we go. There we go. Which is answer choice D. Okay. So key things, remember, add and subtract. You can't do squat. You can add exponents when you're multiplying them. So in these instances here, and then you can divide exponents when you have them together and things. Or when you're, so if this was 499, over 399, we then we subtract these two and we'd be left with 100. Okay, equals x. So remember that when you have bases that are being, exponent bases being divided, that you subtract the two. So I hope that clears up a couple things, and that you have some clarification on those. So good luck. Thank you so much.